August has been the month of asteroids passing close by Earth. Not just one, but three. On the 8th of August 2025, 2 asteroids the size of a 30-metre story building passed 3.2 million miles from Earth. Now that doesn't seem very close. It's the equivalent to 3.4% the distance between the Sun and the Earth. But then something even crazier happened. On the 13th of August 2025, another asteroid travelled even closer to only 18,200 miles from Earth. That's only 82 times further than our satellite, the ISS, or 2.3 Earth diameters. So how close is too close? And why do asteroids even orbit anyway? It's time to ask a scientist.
So we're out here at the Seven Sisters, and if you look beyond, there are these waves which are to do with gravity.
And this is the perfect place to talk about orbits. So, questions. What is an asteroid?
Okay, so a solar system is made up of massive bodies, and these bodies, they are going to chip, right? And so you're going to have all sorts of debris floating around post-collision events. Not only, but a solar system is of course formed through the condensation of the death of a star, essentially. And so you have all this gas. Well, this gas, it's super massive enough to create a solar system and more. And so the particles in this gas condense, okay? And so they're going to start forming planets. So before you get what we think of it as a planet, you're going to get a body, and this body is going to just be rock, for example, like our moon, and that's what an asteroid is. And so these rocks, they're just floating out there. But if enough mass accumulates, then you have something large enough that you can start to get layering, and you can get various layers to the composition of the interior of this body, okay? It's going to become more round. Asteroids tend to be very wonky in their shape, but if you have all this mass, suppose I'm standing at the top of Everest and the peak erodes, it's going to fall down. And it's going to fall down into any kind of crevice. So over time, large bodies have a tendency to become round.
What's the difference between an asteroid and a comet?
It's just a question of distance. So a comet is further outside the solar system, and so when it eventually becomes closer to Earth's orbit, of course, because it's come from so far away, it's very cold, and now it's getting closer to the sun, where we are, and so it's melting. And so this predominantly comets, if not the rocky center, they're certainly a giant icy particle, and so that melting is what we then fly into. An asteroid, on the other hand, is literally just a rock, and it tends to be a bit closer to the sun.
Why is there an asteroid belt?
So between Mars and Jupiter is this belt. Now, why is it there? Well, if you realise that the Sun is this massive star, and it's pulling at those asteroids one way, and Jupiter, this largest planet, is pulling the other way, it then leads to this area in our solar system where there's very little gravitational force because the two cancel, and so there's this area where the lack of gravity prevents the asteroids from clustering into a planet themselves. And so perhaps if Jupiter was smaller, those asteroids would either clump together into a planet of their own, or some of them would join Mars and Jupiter.
If you haven't already, make sure to like and subscribe to our channel to support what we're doing. So in answer to my earlier question of how close is too close when it comes to asteroid flybys, the answer is anything under 75 miles would enter the Earth's atmosphere. So that is too close. But also, if it's too close to a satellite and it's under 22,000 miles, that means that it's entering our satellite zone. So that second asteroid on the 13th of August actually did enter our satellite zone. So that's genuinely very close in space terms. What is an orbit?
Okay, well, in order to explain an orbit, I'm going to start with Newton's explanation, okay? So imagine he was sitting there and he knew, as all educated people knew then, that gravity, of course, was a force that pulled things down. This was what the ancient Greek philosophers had come up with, and it was the height of human knowledge. Things fall because they do, Aristotle. And Newton comes along and he's sitting under a tree, and apparently, so the story goes, an apple fell on his head, and he suddenly realized, wait, the idea of things falling for just because they do is incomplete. It's not universal. So he came up with universal gravitation. He said, if they fall down towards me, I'm falling up towards them. So in other words, all masses attract, it's just that they have an inertia associated with their mass. So the Earth is so big that you don't notice the Earth, a giant apple, falling towards the first apple, you see? And so every apple is attracted to every apple, but the more massive it is, the greater its inertia, and so the less it moves. But when you jump, you push the Earth underneath you. It just doesn't move enough for us to tell.
Why do objects orbit?
Take my star, which I'll call the Sun, and take my planet, which I'll call the Earth. Notice how it rolls. If I remove my star and place my planet, it's fixed in space, it floats. But when I add my star, my massive object in other words, then it falls. But what if it came in with a velocity? Then we get a curved orbit. There's friction on this space-time, but in actual space-time there's no friction as long as there are no particles, and most of space is very low in density. It's essentially a vacuum. I'm a theoretical physicist, so I know the maths behind gravitation. I'm keen to answer them from a rigorous theorist's point of view. So if you have any questions, drop them down in the comments below and I'll do my best to answer them.
How do orbits relate to the sea, where we are today?
So the sea has to do with gravity on two levels that I know of. So the first is the tidal motion. So what happens is, as the Earth orbits the Sun, the part of the Earth that's closest to the Sun has a bulge, and that's the tide. Actually, there are two. There's one on the other side, and that's known as the tidal force, so they come in pairs. But the other reason that the sea has to do with gravity is because it's wave motion. Einstein is there in his patent office. It occurs to him that a force is actually mediated by a potential, okay? What that looks like is a rock on the edge of the cliff at any moment may just erode and fall under the potential of gravity, okay? And so you can imagine that gravity is this potential well, and things fall. And Einstein took this much further, and he imagined that it can have ripples, known as gravitational waves, and the whole thing is very dynamic. And so when I look at the sea, I'm reminded of the rich dynamics, the wave mechanics behind gravity, and in fact all of the other forces. So I hope you've enjoyed these physics explanations, and when you understand forces even here on Earth, and you understand waves and all these things, then you can start to understand the entire solar system and even our universe. If you have more questions or anything to add, comment down below, and if you want to see more videos like this one, like and subscribe.